Okay, here we are at the bottom of page 2 for 9.5, and we're going to look at one of the application exercises. In my opinion, this is just my opinion, but I feel like the application exercises are slightly easier than the Practice Plus. The Practice Plus sometimes brings the two together, although the Practice Plus are really a good indicator of whether or not you know the material, whether or not you're starting to become test ready, because you're able to do multiple things at once. And really that's what the test is after too. Can you handle following the directions, translating, solving, checking your answer, all these things all in one situation. But anyway, let's look at the application exercises. Again, because we're in the section on radicals, you can expect a radical to show up and that we're going to have to solve, okay? So we can expect that there's going to be a radical in the equation and that we're going to have to solve for the variable, which means we'll use our steps that we've been using. Get the radical alone, square both sides, solve from there, check our answer. So let's see what it says. When firefighters are working to put out a fire, the rate at which they spray water on the fire depends on the nozzle pressure. By the way, page 586, number 56 is where I'm at. I know that on camera it's probably too hard to read this. It's pretty visible once you print out the notes, but you may want to follow along in the book as well. The formula F equals 120 times radical P models the water's flow rate, F, in gallons per minute in terms of the nozzle pressure, P, in pounds per square inch. Use this formula to solve exercises 55 and 56. So actually this information is a little bit further up in the book. If you go right to 56, you'll see this question. What nozzle pressure is needed to achieve a water flow rate of 720 gallons per minute? And you'll have to kind of scroll back up above number 55 to get the critical information that you need to get things started here. So we've read it once. Deep cleansing breath, and let's read this again. So firefighters are working to put out a fire. Rate at which they spray water depends on the nozzle pressure. The formula F equals 120 radical P models the water's flow rate. So this is the flow rate F in gallons per minute in terms of the nozzle pressure P. So P is the nozzle pressure. So I'm just kind of highlighting what they're giving us here. And we're going to use this formula. Okay, so we know we're going to use this. F equals 120 radical P as we attempt to solve 56. What does 56 ask? What nozzle pressure is needed to achieve a water flow rate of 720 gallons per minute? So they're asking what the nozzle pressure is. So our goal is to come up with what P equals the nozzle pressure. So our goal is to find P, the nozzle pressure. Which means that since we have both P and F unknown in our formula, they're going to have to give us F, and indeed they do. Water flow rate of 720 gallons per minute, our flow rate. So F equals 720. That's what we're going to start by plugging in. Instead of F, we have 720 equals 120 radical P. The goal is to get P all by itself, or I'm sorry, the first step is to get radical P all by itself. So we're going to go ahead and divide both sides by 120. And you get radical P is equal to 720 divided by 120 is 6. Once the radical is by itself, we square both sides. And the square undoes the square root. That's its entire job. It doesn't change what's on the inside, just kind of releases it, it frees it, brings the P out there. And then 6 squared is 36. So our pressure here, and this is pounds per square inch, we have 36 pounds per square inch. And of course, before we want to make, before we say, hey, that's the answer, let's just double check it back in the original equation here. Square root of 36 is 6. 6 times 120 is 720, so it does check. So it checks. 36 is a solution. So 36 pounds per square inch is the nozzle pressure needed. Okay, and then you'll finish up that section with some review and some preview exercises, and we will see you during 9.6. That should be the next video.